watch this back later. Alrighty, we are resuming our unit 5, which has thus far been about classes once again. We have talked about constructors in more detail. We've talked about the public and private access specifiers, accessors and mutators. Today, we're going to dive a little bit more deeply into methods again. There we go. So methods are blocks of code that we can call over and over again, letting us reduce the amount of code that we are required to write. We can use that code repeatedly, meaning we don't need to copy and paste a bunch of stuff. So what 4 things are required for a method's signature?
Access specified.
Access specifier. Oh, we gave answer 2 accidentally. Return type. What is after return type?
Name.
Name and
Parameters.
parameter list. Absolutely correct. So those are our 4 things that we need for the signature of a method. So for example, public void set width with our int new width as a parameter. If we go back to some definitions, some vocabulary, our formal parameters are the variables that we have listed in the definition for the method, and the actual parameters are the values that are passed to the method when we call it. So my set width, this new width variable is my formal parameter. This value 6 is the actual parameter being passed to new width. That doesn't line up at all. I think this line is longer than I expected it to be for some reason I don't understand. So the types of your parameters do not need to match the return type of the method. Of course, you can have a method that returns a string and gets an int as a parameter, and that works just fine. However, of course, your formal and actual parameters do need to match in type. You can't have an int being sent where you're expecting a string. That just isn't allowed. The value of the actual parameter is used to initialize the value of our formal parameter, which is then used throughout the code in the method. So if we have 2, which of these branches is going to run?
And else if n equals 2.
Else if n equals 2, return 2. That is correct. So we will return 2. So my word num is going to equal the string 2. We will print the string 2. So when our actual parameter is primitive, int, double, char, boolean, any changes to the formal parameter will not have any effect on any variables that were passed as actual parameters. Lights turning off. I hate it. So if I have my string number int n, I'm making my num equals 2, and I'm passing my num, nothing is going to change to in my num. However, when our actual parameter is a reference type, if it is an object, the formal parameter will be an alias of that variable. So any changes that are made to the formal parameter, it's the same data as the actual parameter. They're pointing towards that same object data, meaning that changes will be reflected on the outside. So if I have a rectangle object, say new rectangle 5, 5, and I print it out, my rectangle, we should see width height or width 5, height 5. If I call reset rect of my rectangle, passing my rectangle into this method, r.setWidth 0, r.setHeight 0, and I print my r out here, even though we used the parameter r, my r has been affected because it is different, or not different, because it's not different, because it is the same exact reference. So they are going to be changing the same object data. So if we implement that same code in my program.java in a class that is not the rectangle class, we need to call those mutator methods for the width and height values for our rectangle, like we saw I was doing before, r dot set width, r dot set height to 0. If I were to implement this code, that same method inside of the rectangle.java class, we don't need to call those mutators because we are able to access the private data of a parameter as long as we are in the same class as it was defined in. So if my parameter is a rectangle and I'm in my rectangle class, I can access this variable r's instance variable because we're in that same class where its type was defined. Does that make sense? Cool. So if I try to do this exact code, r.width, r.height equals 0, in my program.java, or not in the rectangle class, we would get an error saying, hey, those variables are private. Wouldn't work. So generally, it is going to be a good programming practice to only modify objects inside of methods where that is a required feature of the method. If we make changes to our objects in random methods, we can cause confusion in our overall program. Our object might start working in ways we don't super expect. So we want to make sure that we are limiting our object modification to very explicit places where we want to be updating our objects. All right, our other topic for today is the static keyword. We are diving a little further into what it is, how it works, what it means. So anything in a class that has been marked as static can be called or accessed without the need for an object of that class type. It is referenced from the class name itself. As a reminder, everything in the math class is static. Instead of needing to make a math object, I just say math.abs. I can say math.py. Math.py is a static variable in the math class. Abs is a static method in the math class. Both of them are accessed from the name of the class instead of from a math object. So because static methods belong to the class as a whole rather than individual objects of the class, you cannot reference or talk about instance variables or non-static methods from that class from inside of a static method. So if in my rectangle class, I tried to make my getWidth method static and return the instance variable width, Java is going to get mad saying, hey, you cannot reference this non-static variable because it's an instance variable. Each individual rectangle is going to have its own instance of the width value. The entire rectangle class doesn't have one width, and not every rectangle has the same width. So width shouldn't be static. Width is an instance variable. I can't access it from a static location. I can't say rectangle.getWidth because not all rectangles have the same width. Now, if I try again to call non-static methods, getWidth and getHeight, both are non-static. They both reference instance variables. Once again, cannot access those because we're not directly accessing our instance variables from this method, but we're referencing methods that reference instance variables. So we can't call non-static methods from a static context is what it's called. So from inside of a static method, we can't call non-static things. Does that idea make sense? Why we can't do that?
Isn't it just non-static? You can't call them in general?
So if we're in a non-static context, we can still call non-static things. So like if we go back to here, like if I'm in my reset rect, I can call in the rectangle class, I can access my instance variables because this is a non-static method. So they're they're allowed to be interacted with because I'm not in a static context. As soon as I go to a static context, instance variables are off the table. You're not allowed to touch those because those are individual to each instance of the class rather than belonging to the class as an entire instance, or as an, sorry, not instance, as an entire being. Does that clarify it a little? Okay. So while we are not allowed to use non-static things from a static context, we can't use non-static methods or variables from a static method. We are allowed to use other static methods. Let's say we were adding a method to the math class, public static double square num. We're getting a double as a parameter. We're going to return math.pow to, or x to the second power. We could technically just call pow because we're in the math class. And since pow is static, we're in a static context, that's totally allowed. And we are allowed to call static methods from a non-static context. You can call these math methods from a non-static method because those are referencing the math class as an entire. They're not like, we can go to more broad, we can't become more specific. We can't grab from a specific instance when we don't have one. But if we are in an instance, we are allowed to look at the math class as a whole and use its POW method, for example. So static methods are also allowed to use static variables. Like static methods, static variables belong to the class as a whole, and every object of that class type shares that static variable. So if you are able to make objects, all of those objects will have the same exact value of that static variable. If you update it in one instance, it'll be updated across all instances. And you can also just reference from that class dot, that variable will just give you that value that all of the instances share. So let's, for example, say we want to keep track of the total number of superhero objects that have ever been created using a variable int num superheroes inside of the superhero class. Every single time we create a superhero object, we want this value to increase by 1 so that every superhero knows how many superheroes exist. If I have my private string name, private power superpower, private int num superheroes, if I try doing this as an instance variable, I'm going to initialize it out here so that it is given a value. And then my public superhero, hero name, power, I initialize all my things and say num superheroes plus plus. I'm going to add 1 to my number of superheroes. Now, each time I call my constructor, each time I instantiate a superhero object, we're only ever going to get 1 because that num superheroes is an instance variable. It's unique to each individual instance of the superhero class, where if I add static, but private static int num superheroes, now every single superhero instance variable is going to share that value. So we can make this get num superheroes also be static because it's referencing a static variable. And to prevent some confusion, if we want, we can write class name dot variable to access our static variables. It doesn't change the functionality very much, but it can add a little bit of extra clarity. So now that that variable is static, it is updated across every single superhero object each time one is initialized, because we are incrementing it inside of our superhero constructor. We initialized it to 0 outside of the constructor. So each time we create a superhero, we will add 1 to that value. So when I call my superhero constructor for duper, it becomes 1. When I call my superhero constructor for flooper, it becomes 2. I've created 2 distinct superhero objects, and it's keeping track of that. And we're accessing that static method, get num superheroes, either from the class name, or we can access static methods from an object. Those are okay if we want to do that. When we have a method that is static, we can access it in either format. Both are valid. Does this additional information about static make sense? Sweet. Okay. Yeah, one thing to keep note of is, since static variables should be able to work without an instance, we want to initialize them where we're declaring them rather than inside of the constructor. So if I wanted to say, oh, there's already 50 superheroes, and then each time I call my constructor, add 1, we would say private static int num superheroes equals 50. We wouldn't set it to 50 in my constructor because that would reset it to 50 every single time and then add 1. Yes, Alex.
Can we change the value of a static variable within any like class?
So it's going to depend on its access specifier. This static variable is marked as private, so it can't be seen or accessed from other classes, but it is static. So it's the same across all instances of this class. So we still create a getter method. We still create an accessor to retrieve its value. But it's the same across all of our instances.
Okay, thanks. And then what about like in a non-static method? Can you change that static variable?
Yeah, so the constructor is non-static because constructors can't be static. They have to deal with instances. That's the whole point of a constructor. So in my constructor, where I'm initializing my instance variables, I'm changing my static variable. I'm increasing it by 1 each time. So we're totally allowed to interact with static variables from a non-static context. We just can't do the other way around. So if I do a little annotation, so static here. Variable context. So if we are accessing a static variable from a static context, that is okay. If we are accessing a static variable from a non-static context, that is okay. If we are accessing a non-static variable from a non-static context, that is okay. If we are accessing a non-static variable from a static context, that is not okay. So there's only one direction where this doesn't work. We're not allowed to access instance things from a static location. Every other direction is okay. Does that make sense?
Yeah.
Okay. Alrighty, I think that's the last slide. Yes. Any last questions before I unlock modules for y'all? Cool. I will stop our recording.